Good evening, y'all. Welcome back to another Sunday Night Electronics Bash, Fundamentals of Electronics and Programming stream. I'm Jeff. It's nice to be back with you again on this Sunday night. We'll get the little timer going since, as always, we're going to give stragglers just a few minutes. There it goes. Just a few minutes to catch up with us until we dive into tonight's topic. We got a lot of the regulars out there. Hi, Palmer. Hi, Nate. Hi, Chris. Chris is gave us our 10 minutes warning to places. Chris, I heard a rumor that your place of work is maybe going to have people back on site, so there might actually be like a 10 minutes to places at some point in the near future. That'd be pretty cool. Yeah, it's nice to be back. I was just saying to my wife, it feels like about 100 years since we've done this. I know it's only been 2 weeks, and I can't tell, frankly, if that's because time is really squishy right now in pandemic times, or if it really... I don't know. It's very strange. I sat down and I was like, what am stream? How do camera? What lights do? But here we are. We're back and we're just gonna roll through it. I'm really excited for tonight's topic, where we're gonna talk about getting data from the internet and doing things with it in Python on the Raspberry Pi, which is kind of the internet is kind of a big wide open topic, of course. So we're not going to touch on everything you can do with the interwebs, but we are going to touch on a lot of interesting and useful things you can do in a couple of different ways that you can access data from the web, either from websites or via a more programmatic interface to get specifically data off of specific websites. So that's going to be a lot of fun. Tonight I am drinking a... Well, you can't... Well... I'm drinking a Glare. I'm drinking a beer that's just Glare. I'm drinking a Half-Acre Lagertown Oktoberfest. And as y'all know who've been with us for the past 23 of these things, I'm not an Oktoberfest guy. I really prefer IPAs, but the Half-Acre one, which is just around the corner from us here in Chicago, is... The Lagertown is like somewhere between a lager and Oktoberfest. Like, it's weedy, it's a little bit spicy, it's really quite good. So that's mine of choice. Curious what y'all are drinking. As always, if it's not alcohol, if it's not in your jam, no pressure, but I'm curious. Chris says, I'm not going to show you the entire internet. Sadly, it was just a little bit too big to download. Like, actually, you can't see it on the screen next to me. I'm downloading the whole internet, but it's taking a little bit of a while. I'm not really sure why. That'll be a fun. That is a thing that not download, but that is a thing that some people do, especially in the IPv4 internet, is port scan the entire internet, right? You basically send out a request to every single possible IPv4 IP and see what's on the other side of it. You know, are there things that are vulnerable or exploitable on that side of the internet? That's not something we're going to be doing tonight, but if that's your jam, good on you. You can watch my After Dark stream where we hack the internet. That seems unlikely. That's not quite the vibe around here. Oh, Palmer says, are you getting buffering on the stream, or is it just Palmer? Ooh, good question. On my end, Palmer, my like the only status I get is like it's green. But if there are stuttering or buffering issues, that actually would be good to know from y'all, so I can swap some kind of buffering or latency setting on my end before we dive in, because we got a lot to go through tonight. We're gonna kind of slam through it, which I'm stoked about. But if anyone else is or isn't having issues, jump in and let Palmer know, just so we're on the same page. Nate seems it sounds pretty good. Awesome. Speaking of, but just right before we dive in, I wanted to do a quick shout out and a big thank you to Nate, who, after all of the shenanigans of our class a couple weeks ago with mic issues. I mean, you remember the mic just like cut out all of a sudden. We switched to a different mic and stream control issues. Nate actually hooked me up with a new microphone. So it's a little bit more reliable than the setup I was using before. So thank you, Nate, for that and for helping the audio on this stream. I was still playing with it. So soundies out there, Palmer, if you have opinions on placement or EQ, I would love them. But I think it's really going to help with the reliability. So really big thank you, Nate. Super cool of you. And for this and for the couple other toys that I think are still on their way. So that'll be a lot of fun. It's super cool. I really do appreciate it. Thanks, Palmer. Getting Palmer to say I sound great. Palmer is a picky EQ man. I know from personal experience, so I'll take it. Speaking of, I have no segue at all out of this. Let's talk about the internet, shall we? I guess this all to say, if my stream controller does crash again, I've built a little replacement for it in Python on my computer, so we have a backup this week that's not just me flailing around for a while. But hopefully we won't need it. Hopefully we'll be able to just like keep rolling as we talk about Raspberry Pi and the internet. So real quick, as we get into this, let me close up this little bar here. The couple of libraries, the packages of code that we're going to be working with today are two primary ones, one called Beautiful Soup and one called Requests. These, at least on my Raspberry Pi that I set up, a few weeks ago, these were pre-installed in the Thonny IDE, so I didn't have to download or install anything. If for some reason in your setup, if you're not using Thonny, if you're using some other environment, these are the two packages that we'll be playing with. The Beautiful Soup library, specifically in the Pi Finder that we looked at last time, is called Beautiful Soup 4. So you'll recall if we go into Tools, Manage Packages, and we have this package manager set up here, this Beautiful Soup 4, the fourth version of this library, is the one that we'll be using today. So in any case, if you're playing along at home and you want to download those real quick to play along, great. They are probably in Thonny if you're working in that. Cool. So what are we going to talk about today? There we go. We're talking about getting data from the internet in a couple of different ways. As part of that, we're going to have to talk a little bit about HTML, hypertext markup language, which most people have probably heard of. It is the syntax by which web servers or other people's computers that are giving us information on web pages denote how our pages should be formatted and constructed so that we can have interesting looking websites and not just blocks of text. We're going to use the Requests and Beautiful Soup libraries to do sort of two different halves of that. We'll get into that in a second. And we're going to talk about the dictionary data structure in Python, which I think I teased a little bit last time. We've sort of been working mostly with lists as our data structure that holds data and allows us to sort of step through things. Today we're going to introduce dictionaries, which are a really powerful way of holding data that it doesn't quite make sense to index numerically. So that's going to be a really fun way to get into things. But to start with, before we show like how you get a web page from the internet, I want to talk just really briefly about like what a web page is. What we say when we're getting information from the internet. The internet, as we know, of course, is a series of tubes. That's a throwback to 2006. How old is that joke? I don't know. It's like a set. It doesn't matter. The internet is a series of tubes. Basically, they're other people's computers that we can ask to do things for us. We ask a server, which just means somebody else's big, expensive computer, usually, to give us some specific data by requesting information at a specific URL or universal resource locator. I'm just going to say URL from now on. So we send a request for a specific URL out to the internet, and for the purpose of today, via the magic of the internet, it knows where to find the correct server, somebody else's computer, and that's going to send information back to us. We're not going to get into like how the internet does its thing, although that would be a fun time, I think, but that's for another time. We can sort of ask for data in a few ways. We can ask for data for humans, like we can ask for a website like Google Slides that I'm on just here, which has things like, formatting and buttons and color coding and a scroll bar. So that'd be one way we can ask for data. But we could also, we might want data from the internet that is really just data. We might want data that is, like when we're looking at the weather, for example. When I want to know what the weather is going to be, I go to the weather app on my phone, and it's got like a nice little picture of the sun. It's got, the rain clouds and the 5-day forecast. On the iPhone, it's got like, ooh, it's going to be stormy, so the background is darker tomorrow. Which is great. If I was to write a program that was going to do something with that weather data, all of that information, all that formatting is kind of extraneous. My program probably doesn't really care that there's a little picture of a sun. It just wants to know what the high and low temperature is going to be tomorrow. So we can ask for data in certain cases in a more programmatic way that gives us just that data. We'll get to that in just a little bit. So let's jump in and have a look. Let's just dive into it, how we get website information, how we get internet information in Python on our Raspberry Pi. So we'll start a new program file here in our Thonny IDE. This will be basically the hello world example at the top of the electronics bash page. Oh, I think most of you know this by now, but in case you're new here, also hello, say hi. All of the code and all of the slides for tonight's episode? Stream? All of the code and the slides for tonight's stream are on the website, jeff.glass/electronicsbash. So if you want to play along at home, you certainly can. So the first thing we're going to do is import our requests library. We talked a little about importing last time. That's just the process by which we say to our programming editor, which other chunks of other people's code that we've already downloaded onto our computer we want to make use of. In this case, it's the requests library, which handles, making requests to the internet, right? Let's pick a URL to download some data from. In our case, I'm just going to use my own website. I'm going to say http://jeff.glass/electronicsbash. That'll be our website. I'm going to encode that as a string, right? So it's in between these single quotes here. And again, in Python, single and double quotes really don't matter as long as you're sort of consistent. I've chosen single quotes here. On the example on the website, it might be double quoted. Like I say, it doesn't matter. And then I'm going to use the requests library to get some data from the internet. So I'm going to create a new object. Let's call it, it doesn't really matter what we call it. We'll just give it a name. I'll call it R equals requests.get the value of our URL, and then we'll print out whatever we got back. So if with a little luck and without any typos, it's probably going to make me save this. Yeah, So I'm going to save this as get Jeff Glass's website.py. And if I run this, we should see, we are not, Jeff.glass would help if I spelled the website right. So it gave me an HTTP connection pool error here. And basically I said I can't connect to this website for you, sorry. But if I spell the website right, with a little luck, there we go. So what I get back here, it just says response 200, which I don't know if you've been on the eBash page recently. It doesn't say response 200 anywhere. The responses are basically a web server's way of telling you how things went when you made this request. So you may be most familiar with the 404 response if you ever try to go to a part of a web page that doesn't exist. And it says 404 error, page not found. 404 is one status code that a server might send back as a really shorthand way of saying, there's just no page here. But there's lots of versions of that status code. There's the 403 status code, which is there is a page here, but you're not authorized to see it. There's the 500 status code, which is just there was some kind of internal error on the server. We're probably not going to tell you what it is. It's not your fault, but something's going wrong on our end. The equivalent for everything's going fine is the 200 status code. So if we print out just what we got from this requests.get method, what we get first is just this response code, 200. 200 is just everything's hunky-dory, you got some data back. If we want to see what was actually sort of contained within that response, right, we can do print r.text. So we'll print out the text property of this object R. And this reminds me, I know we haven't talked about object-oriented code yet, so we tossing around some terms like method and property. I believe that's going to be one of the things we talk about next week. So bear with me for now, and hopefully it all will be relatively approachable until we can do a deep nerdy dive on object-oriented code. So if I do print r.text and I run that code, what we'll see with a little luck, it's all of this. I'm going to make this shell down here really big so we can kind of see what's going on. There's all kinds of stuff going on in here. Here's the sidebar, I think, where I link to my friend Kenneth's website. There's a search form. There is, thank you, Chris. When I said next week, old habits die hard. Next 2 weeks from now on the 27th, our next session. Thank you so much. But you can see here is all of the content that is on the Electronics Bash webpage now. Since this is a little much, it's a fairly long page now, it's got 23 different, sets of links and slides and graphics on it. What I would like to do instead of looking at this full actual website, is to start with something a little bit simpler. Why don't I just comment this out for now, and I will say instead URL equals http://jeff.glass/bs.html, which is just a really small website that I put together for purposes of this evening. And if I load it up over here, I want you to be at the computer. There we are. if I come over here, this is what this is what the electronics bash the bs.html file looks like. It is not a website that's meant to be tremendous, not meant to be great. It's just meant to be simpler than the full electronics bash website, which probably most of you have seen. But like, there is a lot of code that's making up this website. This great looking one is a lot simpler to look at. So why don't we go back to the Pi over here, and I'll show you what the HTML that we pull down for that is. So I'll run this code. It'll run, and here, now we've gotten the code for this very simple website. So it starts here. In fact, here, let me clear the shell, and I will run this one more time. And we'll see the entire HTML for this website. It starts here and ends here. It's really very simple. So this will be our play thing for this evening as we start to understand some of these concepts. And actually, in a later example, we will go back and scrape some information from the eBash website, just as an example of like how you would sort of pick out data from a website that has a lot of different content on it. So this is the HTML for this website. Just because this is a little bit hard to see, I think, because I made this website, I can actually show you the code in a more clear fashion. Oh, Nate asks, how did you clear the shell? Great question. In Thonny, if you right-click in the area of your shell, you get the clear function just down here. You also get show plotter, which actually I don't know what it does. Plotter visualizes series of numbers printed to the shell. Oh, that's cool. We'll have to play with that at some point. You don't ever, clearing the shell doesn't do anything programmatically. I found it this past week. It makes it easier for us to see some things as we talk. So let me bring you back over to, no, wait, we're still here. Sorry, I'm dealing with too many different interfaces tonight. Let me bring you back over here, and I will show you the code for bs.html that I wrote earlier in a slightly nicer formatted function. This is the entirety of the website, because if we're going to be parsing data out of an HTML website, I want to give you just a little bit of a taste of like what HTML is and what it looks like. I am not an HTML expert, and you don't have to be either to do any of this, but it's important that we know just a little bit of how HTML is structured so we know what we're looking for. So this is the entirety of that web page. And just to give you a brief overview of what we're seeing here, there are sort of two major sections here that we care about. In HTML, in the same way that in Python or in C, you would encapsulate a specific chunk of code with, say, curly braces, or in the sake of Python, might be encapsulated by indentation, right? You might say for I in list, some stuff happens here. Right? We have this idea of things sort of being encapsulated within blocks. The equivalent in HTML is things being between matching tags. So, for example, this title tag here tells us that the title of the page, what will show up in the little tab at the top of my Chrome window, should be eBash demo page. And we know that that is the fullness of the title tag because it starts with this word title in between greater than and less than single, what we call angle brackets, let's say. And it is closed, is terminated by the same word inside angle brackets with a slash in front of it. So we do title, eBash demo page, /title, and that sort of encapsulates one idea. Blocks can be nested within each other in HTML. So you'll see this head block here has a matching /head tag down here. So all of this in the middle is inside the head block. We've got a little meta command here that just says, hey, this is the font, this is the character set we're using. We have a link out to some styles that we'll talk about in just a sec. And then we have the title itself. So that's everything in the head section. And then we have the body section, what's actually going to show up on our page. So we have a body start and a /body, so we know everything in this body section is what's going to actually appear on our website. And within it, we have a number of tags. You definitely don't need to memorize what all of these tags are and do, but I'm going to show you just a few of the most basic ones, the most common ones, so you can start to like pick out what the parts of a website are for the sake of tonight's discussion of pulling websites apart. Just like all the other tags, every tag has a start and an end. So, right, so even if you don't know what a tag is, right, you would know that electronics bash 913 demo page is contained within the h1 tag. So we've got h1 and /h1. This hello world, welcome to my website, is inside this p tag and the /p tag. The P tag is maybe the most common tag. P is for paragraph. So when you have a section of text enclosed by P and /P, that denotes a paragraph on your page. So if we go back to the page here, that's this paragraph right here. Hello, welcome to my website. When we start a next P tab, here you will find lots of interesting information. That starts a new paragraph down here. As you might have guessed, the H1 tag is what's making this Electronics Bash 9.13 demo page so big. That's a header tag, right? So H1 is quite large. If we step this down to H3 and /H3, oh, you know, this is not a live representation of this web page, so it's not actually going to show up in the way that we want. But if we were to step that down to a smaller number, this would be a smaller header. You have H1, H2, H3, down and down and down. Tags can also, in addition to creating different blocks or chunks of text, can create formatting. So if we look at something like this great, I cracked myself up making this little tiny website. It's like, how like 1998 can we get about this? There's no like flashing like under construction GIF, but I did think about it. Like this sentence here that says, here you will find lots in bold of italics interesting information in underline many forms. We're making that happen with some tags inside of the P tag. So we have a B tag that makes anything inside of it bold. You will find lots of interesting information. B for bold. /B ends the bold of interesting information in U for underline many forms, right? So by enclosing text within these tags, we do different things to the text in the page. There are other formatting tags. For example, there is the unordered list, essentially a bullet-pointed list. And within that, any LI, any list item tags, create a bullet-pointed list. So you open up your UL block, you have some LI blocks, list item blocks, that create your various list items, and then you do /UL to close off your unordered list. And the last thing I want us to see is how links are formed. Links are formed, you know, if we wanted a link you could click on and go to the Electronics Bash page there. A link is formed with an A tag. So we have A and /A, and this particular A tag takes some additional parameters, right? Because we know not only need to say, hey, this is a link, we need to say where the link points to. So inside of this opening A tag here, you can see long before we close it with this angle bracket, we say A, and then the href parameter, the HTML reference parameter, is pointing at, in this case, the Electronics Bash primary website, right? So that's all our opening A tag. Within that tag, we say, click this link, and we know that any text that's between those two tags is going to be our link. We close out our paragraph, we close out our body, we close out our HTML document. Our very first tag is, hey, all of this is HTML. We close that out, and we're done. So that's a really quick crash course through how basic HTML works. The one thing I wanted to throw out, so, you know, that HTML is causing all of the text and the basic text formatting that's happening on this page happen. The other thing that contributes majorly to page layout is what are called cascading style sheets. I sort of glanced over this rel equals style sheet up here. I said it was applying some styles. The information on this page that's, say, creating the blue background, or the fact that there's this awful drop shadow on this header here, those are contained in a separate file, which just contains some more details about, you know, the body of the HTML, you know, website when we show it should have a background color of light blue. The H1, remember that top header should have a text shadow of a couple pixels by a couple pixels, and so on. We're not going to go so deep as to require being experts in HTML or CSS, but mostly I mentioned it so that if you are digging into websites and you can't quite necessarily identify where in the HTML it's causing, say, like, why is this text underlined, or why is this text, you know, highlighted in this way? It may not be contained in the HTML itself. It might be contained in this sort of separate style document that's applying styling to multiple elements on the page. So just a little aside, and I think that's all the HTML and CSS that we're going to need to know for this evening. Both could be, I mean, frankly, a whole series of classes in their own right, and I would need to do some more prep before I taught those. But questions on that before we dive in? You don't get a mute button anymore because the mic's not far from my face, although maybe next time we're together there'll be one in place. Ooh, that's good. How much? What's the... There's no ABV on this. So, you know, we'll just see how the evening goes, and maybe we'll figure it out by the end. All right, so that's a real quick crash course in HTML and CSS. So let's go back to here. Let's get our fake website up here. We'll come back to our pie, and we'll look at how we can, now that we have the ability to get the HTML of a website, oops, of course, delete the fake code that we wrote a moment ago. Now that we can get the HTML of a website, it would be really great if we could parse, if we could, do something with this code to pull values out of it, just so we weren't like dealing just with this whole giant block of text. And that is what the Beautiful Soup library is for. The Beautiful Soup library is an HTML parser. Its job is not to actually know anything about how the internet works. Its job is to take some HTML files and break them down for us in a way that we can work with them. So Beautiful Soup will work equally well with a HTML, document like this that we've pulled directly down from the internet, or with a local HTML file that's just sitting on your desktop or in a folder. It doesn't know where its data is coming from, it just does the parsing. So we put it together with the requests library, which is going out to the internet, and now we have the ability to parse HTML files from the internet. So let's see how we would implement that. This will be basically the Beautiful Soup Hello World demo from the website if you're playing along at home. I'm going to say soup. Let's see, I'm going to need to import this library first. So I'm going to import Beautiful Soup as, I'm going to say as BS4, just because it'd be kind of a pain to keep typing out beautiful, because apparently I can't spell it. And this is just going to be a reminder to me that this is Beautiful Soup 4, which has some slightly different syntax from Beautiful Soup 3. Beautiful Soup 3 hasn't been around in ages, but here we are. So I'm going to see if I remember the syntax for this. I might have to cheat a little bit here. Yeah, Boop. I'm going to say soup equals Beautiful Soup. We'll just go to this example. It's basically the same thing. Oh, it's exactly the same thing. Well, how clever of me. We're going to import our request library here. Oh, I've actually gotten it reversed. So from the BS4 library, from the Beautiful Soup 4 library, I'm going to import a Beautiful Soup object. You remember last time how we imported just the LED object or just the button object from a library? BS4 has some other functionality in it, but for our purposes, we'll just import the Beautiful Soup name. We'll set a URL variable, which is going to be jeff.glass/bs.html. We'll get the text of that website, so we'll do request.getURL.text. So you notice in our original example here, we were doing this in two steps. We were getting the URL, and then we were printing out the text of it. It is perfectly valid to chain these things together in a single line, right? So I could have said requests.text, and then just printed out are down here, right? So if I run that, oops, beautiful, well, if I do the import, right, and I run that, I get the same result as before, right? So, you can just sort of decide for yourself as you go, is it clear to say request.getURL.text and then just print it out? Is it clear to just get the whole object and then print just the text part of it? It's sort of a matter of preference and style. If I was going to do something like this, just as a little bit of a tangent, and say request.getURL.text, maybe R is not a great name for it. Maybe it's, website text is a better name, and then I would print out the website text. Right, just so it was clear what was happening here. And I think in this example, in this example I baked earlier, that's exactly what I do is I call this website text equals requests.get, my URL location, and then I want to take the text only of that URL. Then I'm going to instantiate a Beautiful Soup object. I'm going to say my soup object equals Beautiful Soup, and the Beautiful Soup object needs to know what HTML it should be looking at. In this case, it's just going to be the text we just pulled down from the website. And then the second parameter here tells Beautiful Soup what specific underlying parser it wants to use. There's a handful of them. There's one specifically for HTML5 that's a little newer. LXML is kind of the default and I think the best. Really, there isn't a huge difference between them. If you have well-formatted HTML, they all work essentially the same. LXML also covers HTML5 and all these things. If you have sort of poorly formed HTML, they can behave a little bit differently. But in my experience, I use LXML all the time, and it's never thrown up on me in a way that I don't understand. So for the sake of our purposes tonight, we can always just use the website text, and we'll give it this string LXML so it knows to use that bit of code underneath to sort of decode what's going on the website. So once we've done that, let's just print out the value of our beautiful soup. Let's run that. We run that, and we can see we get basically the same thing as before, right? So now we have, doc, head, meta, we have our style sheet, we have our title, it's all the same data, but now it's contained within our beautiful soup object. So we can do things like the following. I'll uncomment this next line here. If I do soup.prettify, it's going to hand me back the text of our HTML again, but it's going to do it in a way that it's very nicely formatted. So if I run that, you'll see it's now done basically some indentation for us, and it's broken the tags apart. So it becomes now really much easier to see, wait, here's the head tag. Where does that end? Oh, it matches indentation with this /head tag. That's great. Now I can see like where my H1 tag starts and stops. So that's a really little, convenience function, but using this soup method, this prettify method on the soup object gives us basically a pretty printing of what's going on in our HTML. But the real power of the beautiful soup object is once you have some HTML loaded into it, you can just start referencing individual elements from inside your HTML. So for example, if I say print soup.title, what it should do is find my title tag here, ebash demo page, and print that back to me. So let's see if that works. I'm gonna run. There we go. We get just our title tag, right? Title, ebash demo page, /title, right? Now, if I wanted to get just the text within that title, because in a certain way, this is still like a very tiny little HTML website. It's got one tag, it's got some text, it's got another tag, right? We can think of that as its own little slice of HTML and say soup.title.text, and we'll print that out, and we should get just ebash demo page. Fantastic, right? We can start chaining these descriptors all the way down, right? So for example, let's say I wanted to, on my page, find or scrape down for myself, hello world, welcome to my website. Like, I want to have that in my code. I could say, I would start with my soup object. Let's just print that out again. Remember what that looks like. I start with my soup object, and then I want the words within this p tag, this paragraph tag, so I can just say print soup.p. And if I run that, I get p, hello world, welcome to my website. If I want just the text inside of it, I can do soup.p.text. If I run that, I get hello world, welcome to my website, right? So pulling individual information out of individual tags in the website is just as simple as specifying the name of them after your soup object, and if necessary, getting just the text out of them if that's something that you want. Now, let's say that I want to get, for example, this paragraph where I did all this really excellent formatting. You will find lots of interesting information paragraph here. Remember how good this looked? Maybe I want to pull that down and say, well, how did Jeff code up such a beautiful sentence there? We run into a little bit of an issue because we saw when we asked for the p tag, what we got was this very first paragraph. The first p tag on the page. And this notation where we just append the name of the tag to our object, we only get the first instance of that tag on the page. Similarly, if I were to say, looking for these list items down here, our bullet pointed list, if I do soup.li, right, let's try that. I'll get soup.li.text. We'll run that, and I should get, yes, the very first list item. Some of that information will be stored in list. I don't get the other two. But in many cases, it would be really nice, like let's say we wanted to get all of the items that are contained in a list on this particular web page, and not just the first one. We have a method for that as well. Rather than just directly referencing the individual tag that we're looking for with this dot notation, we can use the find all method. And if I say soup.findall li and run that, what I should get back is, instead of a single bit of a single bit of HTML, I get a list, a nice Python list that we remember from last time, that has a list of all of the items on the page with that tag. So I get my first list item, my second list item, and my third list item, and so on. And then I could, of course, let's say I want to assign this to a variable. Let's say all list items, all list items equals soup.findAllList, and I can say, I now treat this like I would any other Python list. I could say print all list items, say index 1, right? And if I run that, I get, all lists. That's not what I call it. All list items. We'll run that again. All list items. Oh, this helps if I spell it the same way both times. And there we go. We get not all information will be stored in lists, but some will, which was the number 1 index of our list above. That's a really easy way to get all of the items under a given type of tag on your page. The only other thing that I want to sort of mention is, as this beautiful soup basic example before we go on to a more complex one, is what if you want to find, here, I'll take you back to the website here. No, to behind the scenes view of what's going on, the button for switching to the Raspberry Pi view and the button for switching to the good night screen that you've seen now twice are right next to each other, which is poor planning on my part. Oh, Nate has a question. Is there a way to pull the text from the list with the bullets? Ah, good question. So, interestingly, if we look, let's see, where will be clearest? Let's come here. If we look at the code for this website, we'll zoom in here a little bit. So here's our unordered list between these UL tags. The bullet points themselves are actually not a part of the text or the HTML itself. They're something that our internet browser is generating because we told it that that's a list item, right? So rather than in something like, Word, where the bullet point is an actual piece of font or text inside the document, in ours, the web browser is saying, oh, that's an LI tag, that's an unordered list, I had better do some formatting to it, I better prepend it with a bullet point. And there are ways when you're styling this to say, okay, I want the bullet points on my page to, to look like this. This is doing some sort of default behavior because I haven't specified how I want these to look. But in general, you can say, I want an unordered list to always be indented this much, to use this kind of bullets, and so on. So if you were looking to do, say, like some functionality where you were stripping the code out of this website and putting the information into your own storage with those bullet points, what you would want to do is something like, find all of our list items here. Let me take you back to the Raspberry Pi. We could do something like find all list items. Here, and let's just remind ourselves what all list items contains at this point. Contains our list of items. So what I might say is, let's see, output list equals list. Actually, I don't know that I need to do that. What I'll say is for item in all list items. And you remember this syntax from last time. This is how we can very easily step through all the elements of a list. So for item in all list items, I'm going to print the item.text. And in fact, what I might do is say print it with a nice dash in front of it here, plus item.text. So when I run this, if I haven't made a typo, we'll see that first it's printing just the full list, and now it's printing out with a dash in front of it each of the items in our list, and then the list item itself with this tag in front of it. So it would be sort of implementation specific how you would want to implement, like, transposing bullet points from the HTML into whatever file type you're working with. By having them listed just as a list item, you sort of get the general indication that this should be a list. I should say, so we're working with the UL tag, the unordered list. There is also the OL tag, which is the ordered list. That's a list that's sort of numbered 1, 2, 3, 4, for what it's worth. Good question, though. Really interesting question. Let's see here. What shall we do? Oh, I want to show one more little thing before we move on to a more complicated example. Delete some of those. So right now, I am finding all of the, let's go back to our example. We were finding all of the paragraphs on the page. So let's print all list items. Right, so we'll run that. So now we're doing soup.find all, anything with the paragraph tag, and now I get a list of all of our paragraph tags here. Actually, I don't know if this will work, but let's find out. Let's say I wanted to find any underlined sections that are specifically within paragraph tags. Let's see, what's going to be the best way to do this, I wonder. I don't know that I'm quite set up for this example, but let me show you if you wanted to get all of the underlined sections within paragraph tags. I could say, for example, all underlined sections equals just an empty list, just something that we can use to hold our examples as we go through. And I'll say for item in all list items. And I guess this is not really all list items anymore. This is all paragraphs. So let's change that real quick. I'm going to use my find replace functionality, or in my case, Control F. I'm going to say find all list items and replace it with all paragraphs. And I'm going to do a blind replace all, but this code is short enough that I think it will work well enough for me. This is really useful functionality if you're changing sort of paradigms like this. The problem, of course, that you'll run into is it will do partial word replacement sometimes. So like, let's say I have an item called graphs and I want it to be called charts sometime later in this code. But if I just say replace my graphs object with my charts object, and I do replace all, it of course over here has found the end of paragraphs, which matched my string graphs, and now I have all paracharts, right? So you have to be a little careful when you're doing this replacement. Is that something I can undo? Not in one fell swoop. So we'll do all list items replaced with all paragraphs, just so we're a little clearer about what we're doing here. And I'll say, so for all of the items that we found in my all paragraphs list that we made up here, I'm going to say print item dot u. So that's going to be any items with the u tag, the underline tag, inside every one of my specific paragraph item. And then actually once I've added that, once I've printed that out, I'd also like to say all underlined sections dot append, which remember is the way that we add an item to the end of our list, item.u. And I probably want to do item.u.text, I imagine, just so we get the actual text of it. For item in paragraphs, I've forgotten a comma here. So for item in all paragraphs, I need not a comma, a colon to let it know that we're starting this loop here. Okay, so we'll run that. None type object has no attribute text. Oh, this is actually an interesting error. So in this case, so I said print item.u.text, but for some of these paragraphs that don't have underlines in them, it's not finding anything to match. Like in this first paragraph, there is no item.u object. There is, so what you get back is this none type object, which is the code's way of saying, hey, I have nothing for you here. But then what we say is like, okay, well, whatever you gave me back, I want to get the text of that object. And Python is basically saying, hey, there's nothing here. There's this object of type none. There's none things here. I can't give you the text of a none thing. And that's what this error means. None type. When you see none type object has no attribute or has no method of something, it means that you've created something that is equal to nothing. So what I might do in this case is say if item.u do these things. This item.u is basically checking for the existence of this item. So if this is none, then this returns false, right? So if exists at all item.u, then we'll do this thing. If doesn't exist at all, do not do this thing. I think this will work for us. Yeah, there we go. Let's see. Let's get rid of our print statement up here just to make things a little bit clearer. I'll run that again. And we'll see that the only thing that we ended up with was many forms. Like the only underlined thing on the website here that was underlined is these words, many forms. You notice we don't get the words click this link because, again, this link down here is not underlined because we told it to be underlined. It's underlined because it's a link, and the web browser by default says, well, if it's a link, I'm going to underline it and make it a different color. You can change how that behaves, but by default, that's what a link looks like, is it's underlined in a default blue color, right? So we just get over here our our many forms option. And now that we have a list of these things, after we're all done assembling them, I could say print all underlined sections, just so we can see that as well. We'll see that we get the text was printed out once, and then our list is only one item long, and the only item in it is this text many forms, right? So that's how we could iterate through multiple sort of sub-objects in our website. Questions, comments, issues, concerns. Brief. You know, I think it was Palmer who clapped last time. I asked for questions when I see that my beer is here and I want to take a sip of it. I think I think it times out okay with how often people may have questions. But either way, I mean, I guess I'm the one on camera and I like this beer a lot. Very tasty. As always, because internet latency is a thing, ask questions anytime. But while we do, why don't we start setting up for a more complicated example? So we've been working with this very basic, let's call it bad website at jeff.glass/bs.html. By the way, if you're playing along at home, either live with us now or in the future when this is on YouTube, I'm going to leave that bs.html file up on my website. So feel free to use that as like an example file to mess around with if you're looking for just like a simple website to like play around with your requests with the beautiful soup library. That one's going to be up there. So enjoy. That's been a great simple example. I do want to show you an example of, this is sort of a contrived demo example, but if you are thinking about building a project around this, the websites you're going to be interacting with probably, I hope, are a little bit better formatted and a little bit more contentful than bs.html was. So let me show you what it would look like to build up a file that would scrape some practical information from a larger website. And for these purposes, I am going to use the full electronics bash web page. So jeff.glass/electronics bash. I am going to scrape some information off of this page. Let's see, what did I say I was going to scrape? Let's say I wanted to get, so on the ebash page here, as most of you have seen, there is a link to the code and the circuit diagrams for each stream under each of these blocks of text here. And let's say for whatever reason, I want to have a list of all of the links to all of the electronics bash pages for record keeping purposes, for linking to purposes. So what I really want is the content of each of these links, or really the location of each of these pages. Maybe I'm going to go through and scrape all the text off of these individual pages next, yeah, right? But an easy place to find them all would be getting all the links out of this page. So let's build up this example, because as we saw before, this page has quite a bit more code on it. One place that we might start, this is a really cool tool that you all already have, I don't know if you know. One thing we can always do in Chrome or Firefox or Edge or any other modern browser, we can view the source of this page directly if we want to. In Chrome, it's under the little 3 dots menu here in the upper right, and under More Tools. Is that right? Oh, it's actually not there anymore. Maybe it never was. In any case, the easier way to get to it is to right-click on any page and hit View Page Source. And I know that's really tiny on the camera here, but I'm clicking on View Page Source. And up we get the HTML content of the page, much like we were retrieving in our Python library, right? So if you're just like, hey, I wonder what the HTML on this page is, go to a website and just click View Page Source. And it gets some latency now. Interesting. Yeah, it's pretty variable. So I have a little peek behind the curtain. I have it configured to be sort of as low latency as possible, but I think latency is determined more by like the local network conditions than the stream here. So it's going to be a little bit all over the place. But if it gets really bad, let me know and I'll see what I can do to tweak it. So view source is really cool because you can just peek inside what's going on your web page. But if you are doing a project like this where you're trying to scrape information off a page, another really useful tool, if you right click on a page just below down view page source here, if you hit inspect, you'll bring up your developer tools over in a console here. Yours might pop up at the bottom of the screen or somewhere else. It might vary based on what browser you're using. But in this developer tools over here, it's really powerful. We have the full HTML of the page still up here, but as we mouse over individual sections, we'll see it'll start to, if I zoom out here, highlight individual parts of the page as I mouse over them, making it really easy to see sort of which parts of the page correspond to which HTML tags. And if it's a little hard to figure out what's going on from mousing over the HTML, there's a little button here in the top right of the console. It looks like a little rectangle with a mouse. If you click that, I click that and mouse over specific elements on the page, it will highlight the individual HTML elements. It gives me a little pop-up of what that element is and what its formatting is. And if I click on it, like if I click on, let's say, this link that I'm interested in here, it will take me over in my developer console here to that part of the HTML. So I can see that link is here inside of an H3 tag. It gives me the text there. I can go up a little bit and see that it's inside all of these other tags that's nicely indented for me here. So for projects like this, the inspect functionality is really, really useful for just like picking out a part of a web page and seeing where the code is that's affecting it. There's tons of other stuff here in the inspect, the developers part of the console. There's some information down here about what styles are being applied to it, what things that it had to compute as it was laying things out. It's a really powerful functionality. But so have fun playing around with that. I like to just go to websites and be like, what's going on here? Let me see the source. Oh, that's an interesting thing to do with HTML choices. But this is a really easy way to start picking out individual things on our page. Real quick. Oh, let me zoom in here so you can see it a little better. I mentioned just earlier that the links were inside of the div tag, which we haven't talked about yet. Div is just that's a little hard to see. Maybe I can drag this out bigger. So where's our link? Let me find our link again. Link is here, and if I scroll up, it's inside an H3 tag, so a medium-sized header tag, and it's underneath this div header here. Div stands for division, and it's literally a class that a HTML tag that exists for the sake of being an HTML tag. It's sort of a container with no other display or properties to it. So it's often used in a situation where you want to group some elements together, but you don't necessarily want to, call that a paragraph or a bullet pointed list. It's just sort of a collection of objects. In this case, what's happening, like if I click on the site origin widget tiny MCE text widget div here, what I think it's doing is it's saying, yeah, so this block of text, this header, this paragraph, these lists and links are all contained. They just need a container to hold them, in this case, so that I could set the background color on this div to be white, and then the next div below it has the background color of gray, just for a little separation, right? So these divs, when you see a div, you just know that it's another HTML tag that's used to encapsulate things, but doesn't by default have any visible behavior until you start applying sort of new functionality to it. Oh, Chris has a question. Chris says, how do I not know about that option to click on the page, always search on the code site for what I need? Yeah, the click on the page thing is really useful. Depending on the functionality, you basically click on the pointer one and you click on a specific element, and then it'll take you to something interesting there. There's also, really, as long as we're being nerds, the network tab here is really interesting. So like if you open the network tab in your developer tools and refresh the page, you can see everything that it's loaded to make your web page happen. So in this case, I can see that loading this website required 18.4 megabytes of resources. And this is the order that all those things took to be loaded in. I can see down here something saying a really long time to load. What is taking so long? Let's see. Let's look in our waterfall view. So anyway, we don't have to be super nerds about this, but all kinds of interesting functionality. We can see what got loaded when and how long it took to load. Let's see, what took so long? Oh, there's an emoji there's a bit of JavaScript that's handling emojis on this page that's taking ages to load. That's hilarious. I love that a lot. In any case, let's go back to scraping all of the links off of this page and bring them into Python. So we'll bring up our inspector. Let's see what these links are. So these are hrefs. They're inside H3 tags, and they're inside some divs. So I think that'll be good enough for us to be going on with. Let's come back over to the Py. Let's start a new example here. So we'll import, again, our requests library, and from BS4, import beautiful soup. Let's clear this down here just so we have a clean slate to work with. Let's see. We're going to try and make a list of these links and then have something to do with them. So let's start with our list of links. List of links equals an empty list. I like to start with a nice empty list. I'm going to be adding things to it just so it's declared up at the top, and I know what I'm going to be calling it for now. Let's start by finding all of the divs that were holding those those links in them. Because, so I have some links down here that I want to pull, but if I just pull all the links in the page, I'm also going to get all of the links to my other sections of my website, this like link to a blog post up here, the link to the recommended resources. I really only want links that are within those divs that we saw earlier, those containers that we saw earlier. So let's open up our inspector one more time. And we'll see if we click on one of those links, those divs. So this div has a class parameter to it. Classes are just a way of saying, hey, this container is of this type. So you can see there's like div class here, site origin widget, tiny MCE text widget. Site origin is like the editor I use within WordPress to build these sites. So it's given me some pre-made class names. You can see that is also contained within a larger div and a larger div and a larger div, but I want the smallest div that I can that contains these links. And I suspect I have a site origin widget, tiny MCE text widget. If I were to go down to the next link on my page, let's see what that's inside of. We'll click on that. I suspect, yeah, so this is also within a class, a small div of class site origin widget, tiny MC text widget. So why don't we first start by getting all the links that are inside divs with this class. That'll be a good place to sort of narrow down some of the links on this page. So we'll say, let's start with all small divs equals, oh, I gotta initiate my soup. Soup equals beautiful soup is capitalized in this case. Beautiful soup. I guess I haven't actually gotten the web page yet, but this will be LXML. I'll make a request to this website. So ebash page equals requests.get http://jeff.glass/electronicsbash and beautiful soup equals beautiful soup of the ebash page dot text. Here, before we go too far on, let's just print soup.prettify just to make sure that we are getting the right thing. And we'll comment that out. We'll see if we've made any typos now. Oh, let's call this get all links in our documents folder here. And I will run it. Good practice, of course, is you're building up these programs to periodically test if what you've written so far works and does what you think it does. So it looks like we are getting the text of that website, which is great, and not getting an error. So that's a good sign. So now I can start parsing through that website. I'll say all small divs equals soup.findAll. I want all of the items of type div, and this time I'm going to provide a little bit of extra information to this findAll method. I'm going to say where class equals, and I'm going to just type over here the div class name that we saw. So site origin widget tiny MCE text widget. Now text widget. Now in this case, actually, you have to do something a little bit special, and this is taken care of for you in the Beautiful Soup library. The word class means something specific within Python. If this was something like href, if we were searching for like links with a specific href, this wouldn't matter. But because class means something specific within Python, and we can tell it does because it's highlighted it for us here in purple inside of Thani, what Beautiful Soup says is like, okay, if you just say the word class, the Python compiler, the interpreter, is going to get really confused. So my name, my Beautiful Soup's name for class is going to be class underscore. So in this case, if I want to find all the divs with the class of site origin widget tiny MCE text widget, I have to use this class underscore name instead. So let's start with that, and let's just print all small divs and see what happens there. All small, well, it would help if I typed it correctly. We'll just copy and paste because that's easier than typing. We'll print out that list. I get an empty list. Why is that? Did I make a typo here? Site origin, I did, dash widget, dash tiny MCE, dash text widget. So you can tell a lot of the process of building this code is hunting down your own typos. There we go. So now, I should have a list of the text of all of the divs that just had that contained our code that were of this type, site origin tiny MCE text widget, which from our best guess is what's the smallest container that's holding these links. So there's still a lot of stuff in here, but that is okay. So what I will do is say, so my list, let's call this a list of ebash links. Remember, it's still what we're trying to populate. So I want to pull this electronics bash link out here. So let's start by getting all the links from all of these divs. So I'll just say all links equals, let's see, how's the best way to do this? let's say for d in all small divs, all ebash links dot append find, let's see, for link in d dot find all a, and we'll do all ebash links dot append link dot text. Okay, so let's break that down a little bit because I was in my own little coding world there. So we're gonna loop over all of the divs we just found, right? We're gonna go through all of them and we're gonna want to find all the links. And so we'll use our find all method here. We'll say d.find all of our A tags, which remember is the way that we denote links. And then we can just step right through that list that it gives back to us. We'll say for a link in this list of links we generate, and we'll add that link to our all ebash links list that we made up at the top here. And then when we're done, we'll just print out all ebash links. Let's see if that works. Need a colon to start our for loop. And all ebash links was not defined, probably a typo. Oh, I called it list of ebash links up here, so we'll change that over to the same notation. Well, see, Thani's did a nice thing here that it does when the thing you're trying to print is really, really big, it squishes it down for you here. So it says, hey, there's 1,800 characters of text here. Do you really want this all? In this case, I'm going to click on it. I'm going to say expand in shell. And now we'll see I'm getting, here we go. So now what I've got here is not the actual link addresses, but what I asked for, which is the text of all those links. So code and circuit diagrams here, code and circuit diagrams here. Actually, a use case for this code, this is not a purely contrived example. One thing I've been noticing for a while and have been too lazy to fix, frankly, is that the formatting from post to post, from div to div on the ebash website is not entirely consistent. So like, for example, if I come back to the, bring you over to the ebash demo page here, or the ebash page, things like what is the language around the full stream is archived, the full episode is archived, code and circuit diagrams here. Like the phrasing is not entirely consistent, nor is the capitalization. Here's a stray I hiding in this link here, which I don't love. Just like a little lowercase I hiding in that link. So one thing I could do is use code like this to pull in all of that text and make a list for me of them, and then I could really easily go through and say, okay, what's the same and what's different, right? But to close up this earlier example, what I really want is not necessarily the text of these links, although that would certainly be useful for proofreading in this case. What I want is the link location of these links. So rather than saying append link.text, I'm going to append that href parameter of that link, which remember is the place that the link is actually going. So if I run that, what I should get is, I get nothing. That's not exciting. Okay, I know why. So none. You see, for each link, it tried to add the link.href parameter. These links don't actually have an href parameter in this way, so it just added a none type object to this list for every link that we have on our page. Not what we want to do. The syntax should actually be, and we'll explain this in just a second here, link, open square brackets, in quotes, href, close square brackets. So if we run that, now we get, this is unrelated. This is something that's been happening in my installation of Thani recently, where Thani itself starts to crash. We'll see how this treats us here. But this is literally, because Thani is written in Python, I get Python errors when I run Thani. Very exciting. In any case, now you can see our list here now consists of all of the individual links that were contained within any of those small divs on our page. So we don't have a link to Kenneth's website or the Makers Muse YouTube channel. It's just the links that were contained within the divs because of how we pull these. Now, to take this one step further, let us get, so we have links to the electronics bash pages, but we also have this blog post here and the links to YouTube. Let's just pull just the pages that are to the electronics bash page. So instead of just blindly appending all of the linked addresses, why don't we say, let's say, we'll make a new variable called link location equals link href, and then we'll say if electronics bash in link, I think I can do this, if then and only then we will add that link to our list. So if I run that, and I get another error. I may have to restart Thani here in a second. I get an empty list. Let's see. Oh, in link location is what I want. I should get... Yeah, there we go. Yeah, it's weird, right? Is it something? It must be something to do with like how request or beautiful soup is operating. Very strange. Restarting Thani always clears this for me. Selfishly, right now, I don't want to restart Thani because I have all the tabs for all the code we're looking at tonight up here. But I usually just restart Thani. It seems to go away for a while. I'll be honest, I don't quite know what's happening. But you see, by including this if statement here, and again, we can see whether a string is within another string using this in notation here. So if the words electronic bash are in our link location, then we will append our link location to our big list of links. And we'll see now what we have is just a link to all of the electronics bash pages. And here we'll print it out a little nicer. Instead of just doing a print the whole list, we'll say for L in list of ebash links, we will print L. Run that off, so just we'll print it one line at a time, and we'll see now I have links to all of the electronics bash pages. Ooh, except for the first three. I wonder if there's spelling differences there. Why don't we say just if electronics is in them? Although that'll probably still get that blog post. Yeah, Interesting. I bet I get the blog post up here. You run that. I don't love that error. It's not giving me tremendous confidence. There we go. Ooh, yeah. Ooh. So there we go. So we could slice and dice this data in a few different ways, right? You could say if Ute is in link location, right? We could get all of the YouTube links. This is all the YouTube links on that page, for example. So once you have this list of links in text, you can kind of slice and dice it however you want. So if you're looking to make a list of all of the electronics bash, pages or YouTube videos or whatever for your own purposes, this would be one way to do it. Questions? Beer break. So very tasty. Had a little brain bubble there. I think the beer carbonation went up into my head. Where I want to take us now is to look at a thing that I kind of glossed over as we were doing this. And again, as always, throw out questions when you got them. That's what we're here for. This is making sense. If you're like, oh, how would you pull this thing out? And I will try and figure it out, or something like that. But I wanted to talk a little bit about this notation here. You remember I started with, wrongly, doing link.href, and that returned nothing. Instead, I had to use this notation, which we haven't seen before. Link, open square brackets, href, close square brackets. That is the notation for a Python dictionary, which is our next topic for this evening. So let's talk just briefly about Python dictionaries. So a dictionary in brief is another way of holding a collection of data within Python. We found many times in this Python series and in the Arduino series before it that having individual variables for things is perfectly fine, but when we're dealing with something that's even a small collection of objects, a list of website links, a list of LEDs to deal with, it's often nice to encapsulate them into some kind of collection so we can either deal with them as a whole, or we can sort of know where in our collection of objects a specific object lives. The way we've been dealing with this so far, of course, in Python has been through lists, right? So from our familiar notation, you could say my list equals 1, 2, 3, print my list at index 1. You remember that lists are 0 index, so index 1 is actually going to be the value 2. Run that. Oh, this is a scratch piece of Python programming, and I run that, and I get the result 2, because that's the number 1 index of our list. Ooh, don't know what that was. So this is our list index, and we get objects out of a, sorry, let me slow down just a little bit. We get objects out of a list by providing the index of the object within the order of our list. So object 0, object 1, object 2. And lists, of course, can contain not just number values, but can contain strings or other objects as well. So if I print my list 0, I get Jeff coming out. I'm going to restart Thani real quick, I think, because that error is making me a little bit worried. Sure, I'll save files before closing. How strange. Thankfully, Thani boots up pretty quick. There we go. So now if I run this code, I get Jeff as the 0th element of my list, right? This was the list that we sort of talked about in the last session. What I want to introduce now is the dictionary structure. There's a few different ways we can instantiate a dictionary. I'll give it my name, my dictionary. I can say, much like I said, when I said list, I created an empty list. I could say dict creates an empty dictionary. But the same way, here, it would actually be nice to have our list syntax up to compare against. So let's say my dict equals, and in this case, instead of defining a list with square brackets, I define a dictionary between curly braces. And instead of just defining single elements separated by commas, a dictionary is defined as a list of key value pairs from which we will access the values by their key. So for example, I could say in this dictionary, my first key is Jeff, and its value is glass. My second key is Arduino, and the key is Pro Mini. And my third key is the number 199, and its value is good number. This in here should be a comma. So in each of these, we have our key, a colon, and a value, and then we have a comma before the next key and value pair. What this allows us to do is reference those values by key. So in this case, rather than saying print my list 0, I'll say print my dict with under the key of Jeff. And so if I run that, I get Jeff Glass because list 0 is Jeff, and the Jeffth element of my dictionary, the value in my dictionary that's referenced by the key Jeff is glass. I'm going to comment this out so we're only printing the one thing. If I say my dict Arduino, that references the value Pro Mini. If I say my dict 199, that is, I get the value of good number. We can also have keys that are a number, keys that are a string, and values that are a number. Right, so the key is a string. Let's call that a string key. And like last time, I'm going to move this down to a new line just so we can still see it on screen, and we'll give that a numerical value. All right, so we'll run that, and we'll say print my dict string key, and it should give us our number back here. So this is really useful for data that is organized sort of not in any particular order, but where it's sort of categorized by a given key value. For example, you could say something like, I could have a dictionary of last names. I could say my key is Jeff and Glass, George, and I'm being lazy about capitalization, of course, and Washington, and Amelia, and Earhart, spelled wrong, I'm sure. Sorry, Amelia Earhart. But now, if I wanted to get somebody's last name only knowing their first name, I can reference them by the key, right? So I can say last names, what is the last name of the guy named George? And the value of that key is Washington in this case, and that's what we see down here. So what happens when we try and reference something in a dictionary that's not there? Like I say, what's the last name of Steve? It will throw an error. It says, we get this key error, Steve. We have no key called Steve. I don't know what you want me to do. I'm going to throw an error and stop running. That is often a useful behavior, right? If your program is trying to access something in the dictionary that you don't have, throwing an error and stopping is a good thing to do. Sometimes, though, that's not necessarily what you want. So let me show you a slightly different way to get information out of a dictionary. Rather than using this direct notation, which I'll leave up there, I can say print lastnames.get Steve. And in this case, when nothing is returned, I get just a none value back. So like before, when we were going through those links and there was nothing to reference, Python was like, hey, I'm supposed to give you something back. I have nothing here. I'm going to give you an object, but it's nothing. I'm not going to throw up on you, but it's nothing there. So in this case, we got our none type object for Steve, and then we threw an error because we're still trying to do this direct access. So this can be useful in situations where you don't necessarily want your program to crash if your key is not in your dictionary. But you don't want to necessarily return any specific value because there's nothing there. You can also, to this get method, provide a default value. So I say default value here. Here, let's give a default last name in our last name dictionary. Let's call it Jarmsum Bum Fum. It's our default last name. If we can't find somebody's last name, we're going to assume their last name is Jersbuffum. right? So now when I do get, it's going to look for the key Steve. It's not going to find it, and it's going to say, you told me to default to gerbs. That's what I will default to. This can be useful if you're looking for information on something, and you don't know if that information is going to be in your dictionary or not. You can provide a default value so you don't wreck things right away. Let's see. Other things you can do to dictionaries. You can iterate over a dictionary, just like you can with a list. So you could say, for first name in last names. The last names, remember, is the name of our dictionary, and first name is going to take on the value sequentially of our keys. So I can say print first name plus a space plus last names referenced by the key of first name. All right, if I run that, so what's happening here is this is going to iteratively become Jeff, George, and Amelia, and then I'm going to print out Jeff, and then the value in my dictionary that's referenced by the name Jeff. Then it's going to print out George, and then the value in my dictionary referenced by George, which is Washington, and so on. So that's an easy way to iterate through the dictionary. This might get a little bit easier to see if we use a new method we haven't seen called the keys method. So I might say print last name dot keys. Just give us a list of all of the keys in our dictionary. So this gives us this dict keys object, Jeff, George, Amelia. We can also see all of the values that are referenced in our dictionary by doing the dictionary dot values function. So dict values, Glass, Washington, and Earhart. Earhart probably still spelled wrong. So if you just need a list of the things that are contained in your dictionary, and we'll get to practical implementational uses of these dictionaries in just a hot second here. I know it's like, hey Jeff, here's all these things you can do with dictionaries. You haven't told me why I care yet. I swear I'll get you to care. I just want to blast through some of this functionality because honestly, it's not that different from working with a list. It's just referenced by sort of names and values instead of by sort of a linear set of numbers. Let's see, what else can we do with a dictionary? We can print the length using our built-in len function, just like a list. So I'll say last names. All right, we print out we have 3 values in our dictionary by using this length function. Yeah, that's just about it. You can delete objects out of a dictionary. So we could say, using the built-in del function, I can say del last names Jeff. That will remove the key Jeff from our dictionary. So now we see when we print it down here, we just get George Washington and Amelia Earhart. So really easy to remove stuff. Amelia Earhart, no ETH. Thank you, Palmer. I appreciate it. Oh my gosh, you're still stuck on the dictionary. Oh no, thank you. Oh geez, thank you, Nate. I appreciate it. You've been staring at that slide for so, and the side of you can really get this good. This is the good side of my face, thankfully. So you've been staring at that for a little while, which is nice. Oh geez, well thank you for that. Let's see, how long ago did we switch back here? I guess I was saying implementation details. So just to show you those brief examples again here, how we can get the length of our dictionary using our len function. So last names, len last names gives you a list of 3 because there were 3 names in our dictionary, Jeff, George, and Amelia. And then we can use the del keyword here to delete entries from our dictionary. So I said del last names under the key of Jeff, and when we printed that out, we just got George Washington and Amelia Earhart because the Jeff key is gone, if that sort of makes sense. One last little technical detail before we go back to using these dictionaries to parse our websites, which I know is like the implementation side of things in this video, what can and cannot be these keys and values, because unlike lists, there's a slight limitation here. We talked about these lists earlier. These lists really can be lists of anything. They can be numbers, they could be strings, they could be our LED objects from our GPIO0 library, they could be requests objects that we bought down from websites, they can kind of be anything. In dictionaries, the values that we reference can be anything, but the keys can't always. And let me show you what I mean. Let's see. Let me use the GPIO0 library as an example. So import GPIO0. Let's see. Let's do this a little better. From GPIO0, import LED. I might have to pull up the code from last week and make sure I'm doing this right. Just make sure that it imports. Oh, last names. Yeah, I've deleted a bunch of code. Let's delete that. And we'll come back to just having my dictionary here. We'll make sure that runs. Very good. We will say green LED equals LED on pin, I don't think, let's say it was 16. That compiles just fine. If I wanted to have, say, rather than having a list of LEDs by name here, and it doesn't really necessarily make sense to have our LEDs in a list, because between green, red, and yellow, I mean, I guess there's a natural order. There's kind of a traffic light order to them, but like having them in a 0, 1, 2 order might not make sense for our application. So instead, what I might do is, instead of defining our 3 LEDs up here, it might be nice if I could define, say, the dictionary with the key of green is an LED with parameter 16, and with the key of yellow is an LED with parameter 20, and with a key of red is an LED object on pin 21. I think those are probably wrong, but that's all right. But if I run this, this will run just fine. And then I should be able to say, my dictionary, I want to get the LED object that is green dot on. And of course, I've gotten the I think I've gotten the pins wrong here. Let's do this for real. We have the technology. Let's do this for realsies. Let's go to our electronics bash code from last week. We'll pull up our LED code here. So here, red, yellow, and green. We'll bring that LED code in. And we'll just comment this out. I'm just going to use this as reference. So red is on 20, yellow is on 21, and green is on pin 12. Okay. And green LED on. I think this is right. I didn't check the wiring before, so we'll see if this works. Oh, it does. Here we go. We'll bring the pi and the table in there. Yeah, so kind of a morass of wires back there these days. But now we'll see we can use our dictionary to turn our LED on and off. LED on, LED off. So this might be, for your application, a more natural way to think of referencing these LEDs rather than as objects 1, 2, and 3 in a list. Now they're in a dictionary, and we can just refer to them by their number. In fact, calling this my dict might be silly. I might say this is my LEDs. My LEDs, green, dot off. And of course, now we're not bound by any ordering of them. It doesn't really matter what order things are in a dictionary because they're not referenced in order that they're added. So I could do yellow, green, red, and we'll see. Let's see, does the blink function work? Yeah, there we go. See that blinking away? Let's turn that off for a second here. So for a lot of applications where you're working with non-sequential data, dictionaries are kind of a more natural way to think of how your data is organized. But to come back to a point that I was making just a moment ago, there are just a few little limitations on how you can define your keys in your dictionary, and that is this. I've been trying to think of what the use case for writing this particular example I'm going to write is, but for example, I could say my reverse LEDs. Let's say instead of wanting the LED, the key that we look at things up by being the name of the color and the object being the LED object, let's say I wanted to give it an LED object and then have it give me the color. I guess that could be something I wanted to do. But for a lot of code that we're writing, we know what the color of the LEDs is because we installed them ourselves. But just for the sake of demonstration, let me show you what happens here. The LED green and close brackets. Now when I try and run this code, let's see. Reverse LEDs equals this string, and we'll see. Ooh, it's crashed. It's crashed even before it got to the error that I wanted to show you. Pin 21 is already in use. Oh, it's because I'm reusing the pins on the GPIOs here. Let's see. Pin 21 is already in use. Still crashing. Let's see. Pin 21 is already used by GPIO 0 object on LED equals true. Huh. Oh, interesting. It actually hasn't thrown me an error here, which I was sort of counting on. Maybe it's doing lazy evaluation. To have 2 greens. Ah, interesting. So good catch. This is actually not a problem. You can have 2 keys that reference the same value. You just can't have 2. You can have 2 keys that reference the same value. In the same way that in a list, you could have 2 positions that are the same because they operate different spaces. You can have 2 different keys. So this is looking up by the key, giving you the value in this case. So that's totally fine. So going back to our last names example, you could say last names equals Jeff has a value of glass, and Andy, my brother, also has a value of glass. And that will be just fine. Like say print last names Andy, and it should print. Oh, didn't put a close rotation mark in there. It says print last names Andy is glass, and that's just fine. So good proofreading, but programmatically fine. Probably a design error, but coding-wise, it is acceptable. So this actually hasn't crashed in the way that I hoped it would. So I'm going to do a slightly different example to make this not work out so well, be a little bit more contrived, just to demonstrate. So let's say our LEDs are in a small matrix, a sort of 2x2 matrix, and they operate different positions. And I want to be able to look up the color of the LED at each of those positions sort of by coordinates. So I might say my LED coordinates equals, and I'll make this a new dictionary so I can just look things up. I could say I'll use a small list as my key. I'll say the list 0, 0, so at the start of my coordinates, the LED there, and this is an example, it's of course not wired up on the breadboard, but I'll say I have a green LED there. At 0, 1, I have a yellow LED. At 1, 0, I have a red LED, and at position 1, 1 is a UV LED. Again, just a contrived example. And then print my LED coordinates, and I'll want to get the value at the parameter small list, let's say 1, 0. Right? When I run this, we'll see, so this is the error I was trying to create that I wanted to show off. Because if you're using a dictionary, you may get it too. The error I get down here is unhashable type list. And what it's telling you is this parameter here, this key, must be of a hashable or an immutable type. And we're not going to get too far down the rabbit hole into what that means in the back end, but basically because a list object by definition is an object that can change over time, it's not something that we can use as a key in our dictionaries, because the way that the dictionary functions internally counts on the fact that once you create a key object, it is never going to change as long as that dictionary exists. Now, within Python, strings themselves do not change. When you change a string, you actually are creating a new string behind the scenes. Same with numbers. So, for example, though we could say, my string equals Jeff, and then we could say my string equals my string plus glass, right? It looks like I'm modifying the value of my string, but what's actually happening behind the scenes is it's throwing away this value and at some other place in memory creating a new string called Jeff space glass, and then pointing my variable to that brand new string. So in any case, strings are perfectly valid as keys in dictionaries in Python, as are numbers, as are, it turns out, LED objects and most other objects, but a few specific object types like lists that are what's called mutable, changeable, cannot be used as keys. So if you get this error, unhashable type, it means you're using some kind of changeable object as a key, and you might need to rethink how you're storing data within your program to be able to use an immutable and unchangeable type. In this specific situation, and we'll talk more about even more data structures further down the line, I am sure, but because referencing something by coordinates is a pretty common use case, at least the things that I do with Python, I suppose, one way to get around this, instead of using a list with these square brackets, is to use what's called a tuple, which is the same exact thing except with parentheses to define your collection. The difference between a list and a tuple is that a tuple, once you create it, is unchanging. So we cannot do 1, 0 dot append something. We cannot add things to a tuple once it's created. It'll say tuple object has no object to append. You can't add things to this little list, but because these are sort of unchangeable objects once we've created them, they're perfectly valid to be used as keys in a dictionary setting. That's as far down the mutable, immutable rabbit hole I want to go tonight. I just wanted to say, if you do see that error, that unhashable types, you may need to rethink what data type your keys are for your dictionary. Cool? Questions? It's a little technical. We'll go back to applications in just a second here. So very good. Let's see here. Oh, so let's segue back to where we saw that this dictionary notation popped up, why we started talking about dictionaries in the first place. Come back to the pie. We were in, let's see, where were we? What were we writing? We were in the, get ebash links example was our example. We were getting all the links from our electronics bash page. And we were using, here we go. So we were using the link equals the link dot, and then under the we use these square brackets here, and I promise I would explain them. That's how we went down this road. Not that it was unplanned. This was certainly on the menu for tonight. But so what's happening here is when we do our find all command inside of our beautiful soup library, and we find all of these links with the tag A, what we get back is not just a flat list, but each of these things that it gives back to us, each of the things in this list of links is actually its own small dictionary. In fact, let me say print links. And we'll print out the list of links inside each of those divs as this goes. And we should be able to see, let's see, what do we get here? Printing, I think we're printing out things in a couple different places here. Print links, yeah. This link equals lhref. Okay, so in fact I want to print not the whole list of things, I want to print print each of the individual links here so we can see what's going on. We'll see how this comes out. Yeah, so inside of this link object, we can see the various parts of it. And Beautiful Soup is actually hiding a little bit of the inner content of these things, which is a little unfortunate. But you're basically able to reference each of the inner tags of these objects using this very much like a dictionary notation. So I say I want to get the href object out of this tag, and it's making us reference it using this dictionary-like notation here, if that makes sense. So that's it wasn't quite as clear of an example as I had hoped, because they're kind of hiding some of the behind-the-scenes dictionary work that they're doing from us, which is great that they do. Makes this example a little bit harder to see, I think. But where it's going to be really clear to see is in our next example, where we talk about getting data from websites in a more programmatic way. So far what we've done is basically pull down a human-readable website, either the really awful bs.html one or the full electronics bash website, something that it had all the background data, it had the images, it had the links. We downloaded all of that, and then we parsed through it to find the information we needed. And sometimes that's the only place that the information is available, right? If you wanted to get the list of links to the electronics bash pages, wow, 90 minutes already. Holy cow. All right, we're doing good. We're more than we're more than 2/3 of the way through the outline for tonight. I'm feeling good about it, and I'm excited about these next topics because they're really fun. The punchline of them is, in many situations, what we'd really like to be able to do is say, hey, I don't want the human readable website. I just need some data from your particular service. Let's see, what, for example, let me show you an example I prepared earlier, which I think has its own slide to go with it. Dictionary keys. We might want something that's coming to us not in the form of a human readable website. We want something that comes to us in the form of an API, or an application programming interface, which these days often means a web API. API is sort of a general term for asking for things from a computer, but nowadays it mostly means for asking for data from a website in a way that a machine can parse, and you can leave out, like, I don't need the background images, I don't need the GIFs on your very hilarious page. I'm a program that wants to know, like, what time the next CTA train is coming, or what the weather is going to be like tomorrow, right? We can leave out all that stuff for humans. I'm a program. I just want to know some data. And so we have some special ways of asking for this data from specific services to get that information out. These are usually in the form of a specialized URL that has a base and then some additional parameters that we can give it. So here's one that popped up in my life recently. If you search for something on eBay and you click enter, it sends you to a new web page, which is on the eBay website. It's ebay.com/sch/i.html. Then it has a question mark, and then it has some parameters after it. So from R40, probably the number of results on the page, and this new keyword, this NKW, which I think is new keyword, is the thing I searched for, Arduino, right? So really, behind the scenes, we're asking for some information from this website, sort of in a more programmatic way. So let me show you the example that I want to work with for tonight, which, let's see, where did I put the link to it here? Let's see, is it in my, it's in my outline here. I'm going to just pull my outline up on the computer so I can pull this up. And I will take you to the API for my local train system here in Chicago. So, for example, so if I wanted to know what time the next Damon Brown Line train is coming, the next Brown Line train at the local Damon stop to me here. So this is a very, very nice website. They've done a really clear, nice formatting job. So there's a Brown Line train toward Kimball in 7 and 23 minutes. There's a Brown Line train toward the Loop in 10 or 22 minutes. They can tell from the nice formatting here that, you know, this one is based on actual GPS data. These are just predicted arrival times using the little thing. I have some station information I can pull down. This is all well and good for me, a human. But let's say I wanted to make a little display that showed maybe on a little moving servo or on some LEDs, like how close a train was to being here. There must be an easier way to ask this website for information so that I'm not downloading. In fact, if we use our inspector, we can see how much we're downloading to load this page. Let me open that network page back up and refresh, and we can see I'm downloading 2.5 megabytes of resources just to show this page, which is not unreasonable, but really the total information content that I want, which is 7 minutes and 22 minutes, is like a kilobyte. So it would be great if I didn't have to download megabytes of data to get this information. And that's what something like an API is going to let us do. So I'm going to first introduce how we're going to work with this API, and then I'm going to sort of take a step backward and show you like where I got the information to like how this particular API works and how you can understand how another API would work so you're not limited to this specific example. But let me show you a little bit of the making of the dough, and then we'll look at where you would find the ingredients, if that makes sense. So I'm going to open up a new bit of code here. This will be the CTA naive example on the website if you're playing along at home. This will look very similar to the examples we were just using with a couple of simpler things. So I'm going to use my same requests library because we're still fetching data from the internet. I actually don't need. Oh, here. So this is the page we were just on, right? So I can run this script. This is that exact same page for Damon train stop information. And I can pull down literally those same 2.5 megabytes of information here. And I could parse this exactly like we did the eBash page and figure out like where on this page it has the time of arrival, but that seems like this is a whole mess. I don't want to dig through this to find where that information is. I'd rather use the CTA API. This would be the API basic example if you're playing along at home. So in here, I'm going to import the same requests library. I'm no longer going to use the beautiful soup library because we're no longer going to be parsing HTML meant for a human. We're instead going to be parsing information that comes to us in a format called JSON or JSON. And we'll get to details of that in a second. You don't necessarily need this library imported. This is going to help us print it out a little bit more clearly. So most APIs will give you sort of a base URL to send requests to, and then some parameters that you'll append after it to send specific information. Going back to our slide example here from a moment ago, we might say, you know, something like, hey, the base address for this API is, you know, eBay or a CTA website or something, and then I'm going to have a question mark, and then the various specifics of the request that I'm making will come after that. So in our case, the CTA told me on their website about their API, and I'll show you how to find that in just a second here. That the base URL, if I'm asking about arrival times, is this. It's something that they just chose and set up on their Transit Chicago website. You're going to make a request to lapi.transitchicago.com/API/1.0/TTarrivals.aspx. I can do that. That seems fine. In fact, here, let's do that. Let's say initial request equals requests.get base URL. And then, just so we're not overwhelmed with other things happening, I'm going to do from sys import exit, which allows me to use this exit function, which is going to kill our program early, right? So I'm just basically saying, hey, I'm not going to run this yet. Let's talk about this first part of our code here. So I just say, we'll exit after we do this little bit of running. So if I make a request just to this base API here, and I say print initial request, we get a response 200, much like we expected. If I print out the text of that request, we'll see we get some information back, and it says required parameter, map ID or STP ID or stop ID or STN ID, station ID is missing. So basically it's throwing us a very gentle error message that says, hey, you've hit the CTA's website. I don't know what you're asking for. Please ask more better, right? So we just used our request library to reach out to the URL that they gave us, but we still need to ask something for something more specific. And here's how we do that. In this case, right, they say we need a map ID or stop ID or station ID, and I'm going to pass in a Python dictionary, see, I told you it would be useful, with a list of keys and values corresponding to the parameters that we want to send to this website. And then our response library will take care of formatting that string with the question mark and the sending it to the right URL for us. So I know I'm going to provide a map ID, and I looked up earlier that the daemon station is 40090, so I'll provide that as map ID : 40090. I also, the CTA requires that I provide an API key, which is one very basic method of authentication. And I'll show you the process of doing it on the CTA website just as an example in a second here. But they basically said, hey, we don't want anyone to be able to make unlimited access to our website. You have to submit, like, I just submit like my email and my phone number and my address, and they sent me this key and said, cool, you now have permission to make 50,000 requests per day using this key and no more. And if you need more, you can talk to us or pay us or whatever they wanted to do. But this basically prevents someone from overwhelming their servers. Because if I made 50,001 requests, they would say, okay, well, key DA12F3924, etc. is done for the day. We're shutting that down. You can use this key if you really want to in your own code. This obviously is not the kind of code you would write in production in the real world. There are various ways of like putting this key in a separate file or a separate environment so it's not just sitting out here. This is a scratch key that I made just for this class, so feel free to use it to play around with. I will only get in a little bit of trouble if you abuse it, so that's fine. So I'm passing in this key. The API key object in this case is just called key with my 32 digits that they sent me, a map ID for the station I want, and then I'm actually going to request this output type in this JSON format that we'll see in a second here. And then I'll just use my same old requests.get to reach out to this website. Say with my base URL and my parameters, my params, equal to this dictionary. And this could be called, anything you want. My params, this is just a variable that we're passing into this function. So params equals my parameters or what have you. So let's do that, and let's print response.text, and then we'll stop there again as we walk through this code. So we'll run that, and we'll see when it comes back to us. It's a lot of text. It's condensed it for us here. Let me click that and expand, and we'll see we get this whole big old object here. So it's a CTATT object and something, station ID, but I'm seeing good things in here. We've got service toward Kimball, daemon stop, arrival time probably, heading 358 degrees, very exciting. So in some ways, it might feel like, okay, well, we had a giant unparsable web page. Now we have kind of an unparsable list of data and values in here. But the nice thing is this is not an unparsable list of values. This is essentially a big dictionary that they've passed back to us. By putting things in this JSON format, we're essentially asking them to send back some really simply formatted data that's easy for programming languages to understand. If you're interested in learning more about JSON, the place I would point you to is json.org. Does a really nice job of explaining what the JSON convention is. It's been around for like 20 years at this point, but it's basically says, okay, you're allowed to have dictionaries or maybe dictionaries within dictionaries, and you're allowed to have lists, and that's it. Everything else is not allowed. So it's not a great format for passing like images or binary data or streaming some songs, but for information that's, like what time is the train arriving or what's the name of all the CTA stops, it's a really easy format for computers to parse. And so it gets used a lot for passing data like this around. In fact, instead of using response.text, if we use response.json, it will come in for us as a Python dictionary to begin with. So very similar formatting, except now it is literally a Python dictionary. So let me show you it's a dictionary, right? So instead of printing it out here, let's say I'll set a variable equal to response.json. And before we get into like deciphering what's going on in here, I can see my very first key is CTATT. So let's say print R, and then inside of the dictionary that is R, I'll say key CTATT, right? So we should see the value of CTATT pop up in here, which is going to be this other smaller dictionary, which also has a bunch of stuff in it. But if we run that, we should see our dictionary that now starts with TMST, right? So now we have our inner dictionary here with all of our other information in it. So just by getting our information back in this JSON format and parsing it like a Python dictionary using response.json, using this request library.json object, we get back a dictionary that we can just start pulling information from. So we don't have to figure out, what tags are where and where that data was in the website, and do I have to throw out the background color? It's just handing us a Python dictionary, maybe with some lists in it, that has the information we need. How super cool is that? That is the cool part of APIs, is now instead of having to figure out how somebody wrote this data for a human, we get back data that is in the format that our machine uses. Super, super cool. So let's do some things with it. Here, I'm going to delete these and we'll move a little further down. So I did a little bit of digging earlier down into understanding what's in this dictionary. And we'll see. So what I did here is, let's see. I said my working object is response.json. So I took the JSON of it. I looked inside the CTA ATT object, and then I looked inside the ETA object inside of that. So here, let's close this off a little early. Let's print our response.json again, and we'll see where that is turning up. So, yes, stop at error. Yes, expand. So inside my into my dictionary, I looked under key CTATT. Then inside of that, I have this new dictionary, and with this key of ETA, I have, well, it looks like a list. And it's actually a list of dictionaries. And in this list, every dictionary represents a train, it turns out. So I could say, working object equals response.json.eta. I could say print working object. I think I called it working object because I didn't know exactly what it was at the time. Let's exit there. We'll comment that back out. So this working object, inside of this dictionary, this ETA key referenced a list. And for example, the number one object of that list is this little dictionary. So you can see JSON often ends up in this very, very nested structure, but it's organized in a very structured way. You just sort of end up working your way deeper and deeper into the data. So by the time we get down to this little object here, which to be clear is the dictionary under the key CTA, under the key ETA, and the first object in that list is a train that is heading toward the loop. It's route 412. It's a brown lawn train. It is estimated to arrive at, what is that, 8:55 p.m. It is currently scheduled. It is not delayed. So we have all this really useful data here. Has no heading, interestingly enough. Maybe that means it's stopped somewhere. Or maybe it's slipped into the fourth dimension, but hopefully it just means it's stopped somewhere. So now, once I've got my list of trains here, I'm just going to step through my list using our for item in list syntax, and I'm going to print the value of that with the key, in this case, stop destination. Is that what it is? Or stop direction? Yeah, service direction. So we can see down here from our example, stop direction was service toward loop. Then print a couple of tabs. Doing this /T is how you insert a tab into your strings. I print the value of my stop destination. Then I'm going to print my arrival time. And let's just start with that. So if I run that, what I should get is a list of, well, I get an error because Thani, and I get a list of the upcoming trains. So I get service toward loop at 8:55, service toward Kimball at 8:56, service toward loop at 9:07, service toward Kimball at 9:08. I think what I had done earlier here is because really I only care about these last 8 characters, like the arrival time. I could say I'm going to print this string from location -8 to the end of the string. You remember this is the list slicing notation that we looked at last time. And now I just get a list of, where the trains are heading and what time they're arriving, which might be a lot easier to work with in our code. And now I could start, making some decisions about it in our code. Maybe if there's a train heading toward the loop in less than 5 minutes, turn the green LED on. If it's between 5 and 10 minutes, turn the yellow LED on. If it's more than 10 minutes, then it's not worth running out the door from my apartment, turn the red LED on, or something like that. This is the real value of working with things in APIs is, it took a little bit of time to like dig down into, okay, how is the dictionary structured and how is the inner dictionary structured? But once you're there, you just get the objects in your code to work with, which is really cool. The one thing I wanted to point out as you're doing that digging process is making a little bit of a use of this Python's built-in JSON library. This is a library that comes with the Python installation. You don't have to install yourself. Includes this object called json.dumps, which basically takes a JSON object, these nested dictionaries, and prints them out nicely for you. So after we've printed out our train donations here, I'm going to have it print out our whole list of things. Get an error, but we'll see rather than having that big mess of text that we have earlier, now it's doing some of that. The same way we were pretty printing things earlier, now we have this nicely formatted list of, okay, I can see it's a list, and inside that list, this first object is a dictionary with key and value, and so on. All right, so that's good. All right, then the next item in my list is another dictionary with key and value, and so on. So this json.dumps, which just takes the JSON object you're working with and how far you want it to be indented when it prints out to your screen, can be really handy as you're, parsing through these JSON things for the first time. Oh, geez. Time to restart Thani again, I think. I really am curious what is going on. And why it's all of a sudden seems to be crashing so poorly. So that is the gist of working with this API. I do want to show one more example here. This will be the CTA arrivals example. If you're following along at home, I guess it's the CTA arrival example even if you're not following along at home, but it might not mean as much. Oh, it's the same example here. But we could apply some conditional logic to it. So we could say, for each of the incoming trains, maybe I only care about them if they are heading in the direction of the loop. Because I'm rarely, for those who know Chicago, I'm rarely traveling from Damon toward Kimball on the Brown Line. I'm almost always going into the city. So I could say, let's get the value of the stop direction. So let's say direction equals arrival, and we'll reference the value inside of that dictionary by its key stop direction. And we'll say if loop, and I will have to get the capitalization right here, you recall, in direction, print the stop location. We'll see if that actually does the thing. I don't think it does here. We'll get rid of this if statement for a second just so we can see what the actual formatting is. Oops, what is happening here? Ah, there we go. Service toward loop. No, I think that's right. If loop in here, let's print out our direction objects here. We'll do a little bit of live troubleshooting. I know everyone loves the live troubleshooting. Let's see. We'll see what we can figure out. Service toward loop. No, that should be right. If loop in direction, service toward loop. Oh, no, I think that's right. Did I just do the formatting bad last time? Yeah, there we go. So now we're still getting all these objects, service toward Kimball and service toward loop, but it's only printing out the service toward the loop objects here. So we can start applying some conditional logic to our to the values that we're pulling down from the internet. Yeah. So that is the gist of the CTA. API and APIs in general. Let me take a little segue into showing you, this has all kind of been handled, this is how you work with this API. Let me show you how that information is presented, partly because the CTA actually does a really nice job of presenting their API information. So if we go to the Chicago Transit Authority website and go to their trackers page, let's see, where's my API? Train tracker. Let's see. Oh, this is not here. I'm just going to Google it. Chicago CTA API. Where are you? There we are. The Chicago Transit Authority Developer Center. I'm going to go to the Train Tracker API. This is a really nice layout job. It's like this. The API provides a gateway into near real-time bus and data system, where they get their information. We'll go to their documentation. Ooh, here. Let's go to their train tracker. We'll go to the documentation. and they got some things you should know, like how accurate are their predictions. Most APIs are not this like thoroughly documented. They've done a really pleasant job here. But inside this documentation, it tells you like it's currently a little bit beta. You need an API key that we'll look at in a second here. That's that long string of gobbledygook that told the API that it was me when I was asking for it. Tells you what it covers, what it doesn't cover, where they get their information from, which is very nice. And then let's come down to the API definition here. So this is the one we've been using, the Arrivals API. API provides a list of arrival predictions for all platforms at a given train station. So here's that base URL that I appeared out of a hat earlier. It just told me, it's like, hey, you want to make your requests to this URL. That's great. And then here's the various parameters that you can provide that we will respond to. So we've been using the stop ID. Or do we use the map ID? We use the map ID. That's a specific station. You can also use the stop ID, which is a specific station going in a specific direction, which is kind of cool. You can say, hey, I only want a certain maximum number of results. Maybe if you were writing a bit of code to only show the next upcoming train, you really only need a single result. You only need one train's worth of information, so you might as well only ask for one. You can ask for information with the RT key that shows you a specific route for a train. Remember the brown line train we saw was Route 512, if that's useful to you. And then your key, your API key, is a required parameter. So you provide your key in your dictionary with your unique API key that you got from them. And then it breaks down for you all of the various bits of information they're going to hand back. Your root element, your very first one, is CTATT, and then all the various bits of parameters it's going to hand back to you. So this is, I think, a little bit hard to read, but they also provide some nice examples of how your request will come back to you. So here's like a very nicely formatted, if you make your request to, for example, the arrivals with this key, maximum 1 to this map ID, you get back a response that looks like this. This is a really easy way to look through and say, oh, like this API has information about stops and service and times. That's really useful. But maybe I want information about a specific train. Then I can make a similar request, but to a different base URL, and of course with different parameters and keys, and it would give me different information. You may also see APIs that bring you back information in this XML schema, this XML format, which is another way of sort of returning structured data from a website. It's a little bit harder to parse in Python, so whenever possible, I like to have the JSON version to work with, but there are similar capabilities of parsing out XML, kind of much like you would parse HTML, but that could be a topic for another day. You can get locations of where trains are at this specific time as well. Ask it for a specific train, and it will give you, information on where that train is at the moment. So when you're looking for information, if you're building a train tracker app or a weather app or a trucking route information app, you probably have to go out to whatever that service's development website looks like and ask them for look for the documentation on how their API is set up, because of course will be different whether you're asking for information about trains and buses versus tweets and YouTube videos and various things. But speaking of tweets and YouTube videos, I do want to close out with a little it's not a plug, it's a code example. I realize that sounded like a transition to like, comment, and subscribe. I swear it's not. It's a transition to, one of the nice things, and I want to say thanks to everyone for accommodating the transition to doing this every other week, because it really, it's given me some more sanity week to week, but also it gives me the time to really, frankly, play and explore with some of this stuff, which I had time to do when I was just doing this and was not back at work. And now that I am, I've spent some time playing around with various APIs to generate interesting examples and have fun and try and learn as much as possible about these libraries before we, talk about them. So one of the things I did, for example, was write some code, and this is on the website as well. This is the YouTube stats example. YouTube and of course Google have tons of APIs for getting information and examples, information and data about their services. And one of the things that they provide information on is YouTube videos. There is a YouTube data API. There's actually several different YouTube APIs if you just want publicly available data, if you want private data about your own account or somebody else's, which requires some more authorization process. If you want sort of data in aggregate or data about a specific video, various things like that. There's also an API. APIs don't just have to be for getting data. They can be for sending data into the universe too. So there's an API where you would say, send to this API URL with the parameter, your YouTube account name and your secret password key that we generated for you, and a pointer to the file that you want to upload as a YouTube video. You can upload YouTube videos programmatically via API as well. They're not just for data ingest, they can be for telling other computers what you'd like them to do as well, for example. So one of the things that I did was learn a little bit about the YouTube API, and use it to pull down some information about my own YouTube channel, just for interest here. So this is kind of a long example, and this is kind of I feel like often I'm at the phase this evening where I'm like, explaining this all in detail is not the point. It's just to illustrate that you can use these tools to build up bigger and better projects than we can dive into in 90 minutes. As Nate clocked, it's been a little more. But, not getting too deep into the weeds here, but like, for example, I wanted to get the list of all of the YouTube videos that I have and get some information about them. So what I did was I went to the YouTube API, and they have various endpoints, various URLs for the various things you can ask about. You have to provide those requests some parameters as a dictionary, which we've learned about. And then I use my request library to say, make a request to the channel's URL for some statistics provided by my statistics payload, and then print them out to the screen, and then find some information about the videos and some print that out to the screen as well. So if I run this, and I think my quota should have been reset, which would be good, we can see it's went through, I can't stop it from auto-scrolling, it went through and got a list of all of the IDs. I'll scroll back up in a second when it finishes processing here. It's literally downloading information from the API about my YouTube channel as we speak in real time here, going back through all the videos that I've ever made, and finding, I think, the runtime of each of them. Oh, and this is the current view count on all of them, and I had it sort by that. And it's only printing out ones with Electronics Bash in their name. Let's see. So it went through and it got the list of all of the YouTube IDs, these convoluted strings about my YouTube videos, and then it printed out, for example, the list of all of those, and then it went back to the API and said, okay, now that I have a list of all of my YouTube videos, I want some stats on the video with this ID. Okay, I want stats of the video on this ID. So you can use these API calls together. If there's not one that says return all video information, you might have to say, okay, give me a list of all the videos, and now I want information about each one in turn. And after that was all done, I could come down here and say, okay, well, what is the total runtime of all of my Electronics Bash videos on YouTube? And as of 45 minutes ago, we are over 60 hours of Electronics Bash content on YouTube, which is, frankly, for something that started, literally 6 months ago in a couple of days, 60 hours of 2 full quarters of a college class, kind of blew my mind apart. So use the content of this class, use these API calls to blow my own little mind into smithereens, which is pretty cool. So this was like a fun adventure for me. It's like, what new APIs have I not explored that would be fun to explore a little bit for this class? The other show, Chris says, thank goodness there hasn't been a test. There hasn't been a test yet. The other fun example that I've been playing with this week also uses the CTA API. So the CTA API can give you not just arrival and departure times, but can also give you GPS location for each of the trains. So I wrote a little program here, and let me make sure it's gonna not close itself when I do this. I'll give it like 30 seconds of stick around time. But when I run it, it draws a little map of the CTA itself, or should. Oop. Maybe it was should. If not, I have screenshots of this. Wow, it did crash hard there, though, huh? Close that program. Let's take this back down to 15 seconds here. Let's try that. Let's see if we can get this to work. It did work yesterday. Maybe I just need to leave it alone for a second here. What it's basically doing is it's reaching. There we go. Provides a little map of the CTA. I wonder if it's hanging up on some of the train location stuff now, because I've changed a few things. But what it's doing here, so over the course of an afternoon, I had it periodically sample the locations of a bunch of trains, and record the location, and then it draws a little dot here in the color of each of the train lines. Oh, there's the trains. Yeah, I don't know what happened before. So the train lines on this little map are actually just geolocated to the tracks themselves, and then it draws in the current location of all the trains that are currently running in the CTA system. I wonder why it crashed when I did 30 seconds here. Maybe I was poking it too hard. Let's see if it'll draw again. Yeah, weird. Maybe I have it sleeping somewhere that I don't want it to. Well, this is not the time to debug this program, but yeah, just like just like a little frankly a little show-offy example, but a fun example of like things when you start chaining APIs together, how you can really accomplish stuff. Also stuff like where the roads are on this map makes use of an open available mapping API. The borders of Lake Michigan, ArcGIS, which is a service that provides geographic information, at least here in the States, has an API that you can ask for the boundaries of bodies of water within a specific latitude and longitude box. So I had it pull me down the boundaries of Lake Michigan in Chicago here. And you can see things like, like the little outjuts up by Northwestern, and like Navy Pier is down here in Chicago. So it really, I think, adds a nice amount of detail to this project. There's Navy Pier, here's the marina, like that's pretty cool. So, and all of this is stuff, took some time, but none of it is terribly complicated from what we've done today. Things like I have a get arrivals fund, get locations of the CTA trains, right? Just reaches out to a URL with some information, makes the request, and then parses the information that comes back. It does for everything in that route, find me the destination, find me the next station, get the route. This is how I got like the location of everything. It just makes a request and stores all that data in a file. Like that's all it's doing. So you certainly can do this too. It takes some time and takes some poking at, but like you now know everything you need to know to start interacting with APIs in interesting ways. And there are APIs out there for a lot of things, for transient bits of data, like how many views a YouTube channel has, up to like real-time weather, real-time traffic, mapping data, things like OpenStreetMap, for example, that makes maps available for free online, has an API. You can reach out to them and embed their maps in your own website or their traffic data. The light blue CTA line is actually the river. Oh yeah, yeah. On the on the map here, the blue is a little dark and probably even a little bit darker seen over the internet. You can see with train. Or not quite. Something weird also is happening with the yellow line up here. It did not draw the tracks for the yellow line. I think because there's often only one train active on the yellow line when it's running, the data was coming back in a slightly different format. Like it wasn't coming back as a list of dictionaries. It was coming back just as a dictionary, and my code didn't account for that, and I was too lazy to fix it. So that's why the yellow line is kind of like crashed up here in Skokie for the time being. Because my home automation looks at weather API, doesn't use oh, you totally should use it. Yes, that's exactly the kind of thing that's useful for this. I will say there's a lot of APIs out there that provide information to changing data, and there's APIs out there that provide information to more like static data. Like for example, the boundaries of Lake Michigan on that map are, fingers crossed, not likely to change a lot anytime soon. So the way I've structured my code, and we'll talk about this in some future episode, what I have it do is the first time I ran it, it reached out to the website for the data and brought it in, and then saved it to a file that was in the same directory as the code. And the next time the code ran, it checked. I wrote into the code to say, if that file exists, just use that file. If that file doesn't exist, then go to the website and grab that information again. Just because there's no point in like hammering their website with requests when the data really isn't going to change. In fact, I think that's this here. So here's a parallel example from like tracking the GPS points of the train. I say if we want to rescan, like I have a Boolean variable that says if I want to just force this to rescan, then do this function where I get all the points and then dump them into this file using the pickle library. The pickle library is the standard like write out like some data to a file and bring it back in. Again, we will talk about this at a future time. So if we want the data, get it in and dump it. But if the file is already there, then just load that information back into the file. There's no point in getting megabytes and megabytes of data from the internet just to draw a little map if we already have it on disk. So that's a decent practice, especially if you're building hobby practice like I am. Is minimize the amount of downloading non-changing data if you can. Chris says need to work with Travis and get the blinds to change based on... Ooh, yeah. See, now we're talking, Chris. This is the kind of thing that the Raspberry Pis are really good at, right? Is going back a few weeks is like, why would you use a Raspberry Pi over an Arduino? Stuff like reaching out to some resource on the internet, making API calls. You can do on an Arduino. You can put a network shield on there, or you could use like an ESP32, which is kind of the networked version of an Arduino. But it's a little bit cumbersome. It's a little bit hard to tell what's going on and hard to debug. Doing it on a Pi, really freaking easy, as we've seen today, or at least more plausible for sure. Speaking of things that are more plausible, I have a question for y'all before I get to the closing business, and it's this. I think I referenced earlier, so the thing I want to talk about next time as a programming topic is object-oriented programming. Which is something we've sort of danced around for the past few weeks. But it's a way of encapsulating information and actions into what we think of as code objects that we then ask to do things and ask them about themselves. It's a really powerful topic. That's the coding side of things. But much like this week, we had, getting information from the internet was the implementation side, and Dictionaries was kind of the code side. Next time, I think objects is going to be the code side, and I'm not quite sure what I want the implementation side to be. I haven't hit, like, when I started to unpack like the accessing the web part of this, it's like, oh, of course we need to know about dictionaries and JSON. It's a marriage made in heaven. But object-oriented programming is such a sort of a wide spanning topic. It'd kind of be like saying, okay, next week on our cooking show we're going to talk about pots and pans. Which would be a great show, I'm sure, but it's like we still gotta cook something. So one I want to throw out there and ask you to throw me some ideas or some thoughts as I get into the closing business is what you're interested in learning about, talking about, or asking if it's possible in terms of things you can do with a Raspberry Pi. And feel free to toss out big ideas like I want to know if you can build a robot, or really specific ideas like how would you interface with a UH-74 temperature sensor? Like if there's anything interesting on your mind or anything interesting that you're working on currently. Could be something physically interactive, could be like, how do you make... I don't want to prime you too much in any case, but in any case, if there's things that are knocking around in y'all's heads like, I'm hoping we get to talk about X sometime soon, throw them in the chat. I'd be curious to see what's on people's minds. I will certainly come up with something, so no pressure. But I'm just curious if people have things out there that they're like, I'd be curious to talk about this thing. So let me know. In any case, I will get into some closing business now. Thank you, everybody, for being here on these Sunday nights. It's really, as always, it's a treat. I think I said this at the beginning, but it felt like I was sitting down here and I was like, it feels like so. It felt like so long, and I'm honestly, I miss this group on the Sunday nights that I'm not here. I think the practicality of it, of like actually doing in class every week, is still a little infeasible. And honestly, the next 2 alternating Sundays that I'm not with you on the internet, there are things going on in my life, so that'll be good to attend to. But further down the road, I'm musing about like how it might be still possible to get this group together on a Sunday night and do something nerdy and talk about a nerdy topic in a way that's slightly less structured than a class. Like, is it I just whip out one of these hobby projects and work on it for an hour and people can drop by and ask questions if they want to or not? And does that belong on this same YouTube channel, or does it belong on Twitch? Because this YouTube, the beauty of this YouTube space is like it promotes archiving and recording, and people can come back and watch it later, and they do. And for something that's just like Jeff screwing around making a thing with a thing, is that really something that belongs on this channel, other than the fact that like everyone who knows what's going on here is already here? So I'm not quite sure what to do with that, but like I really did sit down to do this and I was like, oh man, I haven't seen these folks online in like 2 weeks. So not anything that's happening soon. The next class will be September 27th, 7 p.m. Central Daylight Time here on the same YouTube channel. Links will be on the Electronics Bash page, as always, code and slides at some point. Maybe a couple hours before the class, maybe a little farther in advance if I can get my act together, but we'll see what happens there. Palmer, you're such a good in the chat. Yes, it turns out, Palmer, if you have questions, I am on Twitter at JeffersGlass. I do have a website, jeff.glass/electronicsbash, and I keep a blog there of other nerdy things that I'm doing. I'm hoping to have a post up before I, quote, as Chris points out, quote unquote, see you all next. I bashed together a project with Python and not with a Raspberry Pi. It's running on a Windows computer to pull some information on the status of my 3D printer at work, because it doesn't have a great indication because it's all sealed in a box of what's going on inside. So I wrote some Python script to pull its status off of the 3D printer and then show its status on a little stack light, one of those little red, yellow, green automation lights like you'd see in a factory, that's enclosed in a 3D printed box that's stapled to the wall of my workshop. So that's a Python script grabbing the status of the 3D printer and then controlling a USB relay that's turning the various lights on that thing on and off. So I hope to get a blog post up soon about that if you're into those kind of things, and I think that's it's very much in line with what the folks here are interested in. Yeah, it's a cool project, Chris. I got a Prusa 3D Mini for my workshop at work, and it's great. If ever this channel diverges from programming, which I don't know that it will, but someday I want to talk about 3D printing, but I think that's not quite the track that we're on. Oh, Nate literally just said, I think 3D printing would be a cool topic. We have so much more to learn about the Pi. Yeah, for sure. Maybe I don't know, one of the blogs that I've been reading, and I swear we're on the last 2 minutes of this thing, I'm sure, does a nice thing. He's an academic blogger. He writes about the history of technology over time, frankly, is the only way to describe it. But on weeks that he's too busy with his actual job to do things, he does what he calls fireside chats, which is just sort of I want to talk about this and I haven't really prepared, but here's my thoughts. 3D printing might be more for those kind of nights. It's here's not a whole class on how to 3D print, but here's some stream of consciousness, an introduction to, which might be kind of fun. Anyway, yeah, so it would certainly be fun to talk about. Well, and in the days someday when we can all genuinely sit down together and have a beer, that will be definitely on, high on the list of shoot the shit topics. I guarantee. Whether that's a part of this channel ever or not, I don't know. I think we're on the Pi for a while now yet, which will be a lot of fun. But in any case, thank you so much. Please stay safe out there wherever you are. I know that goodness knows there's a lot in the world this week, but please do be safe. Please hydrate. Please treat yourselves well. Please be good to other people. Use this place as a way to find strength to go out and do good things in the world, because you are all such good people. I will see you the night of Sunday, the 27th of September at 7 p.m. Central Daylight Time. We'll talk about object-oriented programming, and we'll do it through the lens of I'm not sure what yet. But as I'm casting my eyes around my workbench here, it's I could hook that up to the Pi. We could hook that up to the Pi. So we'll cause some kind of mayhem, I am sure, somehow. Thank you very much. You are all great people. And I thank you, Nate. Thank you, Chris. Thank you, Palmer. Thank you, everybody out there in internet land. I will see you in a couple weeks. Take care.